This is Claire, Francis, and Ellie with ionic bonds and Coulomb's law. First of all, just a little bit about an ionic bond. They're polar, which means one end is positive and one end is negative, which makes them neutral. For example, NaCl, which is salt. Sodium is the cation and has a +1 charge, and chlorine is the anion and has a -1 charge. So together they have a neutral charge. Is that everything you need?
Yeah.
Okay.
My papers. Properties about ionic compounds. They're usually solids at room temperature. They're very brittle, and most of them, salts are ionic compounds, and they have very high boiling points and high melting points. And most of them form this crystal lattice structure that you see here. And the intramolecular forces between the Na and the Cl that Ellie showed you, those create the compound, and then intermolecular forces keep the compound together in a crystal lattice structure such as this one.
Because they're cool.
Law, like Ellie talked about, this is the intramolecular force that keeps both of the cation and the anion together. So this means that the force between the two, cation and the anion, is proportional to -1 times the charge of the anion times the charge of the cation over the distance squared. So first you would multiply these two to find out what the numerator was. Then you would find the denominator by multiplying the distance between the two atoms. Therefore, the smaller that the two atoms are, the closer the nucleuses are. That would make the force stronger.